In this unit, we will see some common Unix anti-patterns, commands that are sometimes used in a specific flawed way, even though there are better alternatives. Here is an unnecessary thing I often see in Unix shell scripts. We must avoid it.
To use a file as input to a command, do not catenate it and then pipe it as input to the command. Instead, use a simple redirection, which is more efficient and readable.
Another superfluous statement I often see in Unix scripts is the testing of the command's exit code after a command terminates.
For instance, we run a command and then test its exit code to verify it's equal to 0. If it's not, we output an error message. In this case, I echo error. Instead, a more readable and efficient practice is to simply run the command, negating its result within an if statement. Thus, in case the command fails, the error message is displayed.
When we use the sed or the awk command, we rarely need to pass their input through the grep command.
As a first example, consider the command grep pattern pipe awk. This can be simplified by running awk/pattern followed by the action. Similarly, the command grep pattern pipe sed can often be replaced with only a sed command. We pass to sed the matching pattern in slashes followed by the commands to execute on the matching lines. Note that if the commands appear on a single line, all, including the closing brace, must be separated by semicolons.
Modern versions of grep can recursively search through a directory hierarchy. For a number of years I've avoided using this option because it goes against the Unix do one thing well philosophy. A pure Unix approach would be a find pipe xargs grep pipeline. However, this option is way too useful and convenient. Consequently, I've given up and I'm now regularly using it along with the git grep command, which is similarly convenient and superfluous.
Let's see some examples of the grep command line arguments replacing more complex sequences. Consider the case of running grep on a file, searching for a pattern, and then piping the output to word count to count the matching lines. To simplify this, we can run grep-c pattern, which equivalently counts the matching lines. A similar case occurs when searching for a matching pattern through all files in the directory hierarchy. One way is to run the find command on the directory hierarchy, specifying to look only for files. Then we can pipe the output to xargs using grep to search for the desired pattern. A simpler alternative is to run grep-r pattern on the specified directory, which recursively searches for files with matching lines.
When we see an expansion of ls in a for statement, we should consider using a wildcard instead.
Echoing the output of the ls command is the same as simply executing ls. Moreover, iterating through the output of ls in a for loop to execute some commands on the listed files is the same as running for I in star, so all files, including the same commands.
In cases where the awk command is used to select some parts of a line, we can replace it with a more lightweight cut command.
Consider the case where we want to obtain some fields from the colon-separated password file. A solution is to run the awk command specifying a colon separator to print the desired fields. Here I select the first and seventh ones. A better practice is to use the smaller and more specialized cat command, specifying the field separator with the -d option and the desired fields with -f.
We can also often replace the sed command with the exp command, which is more lightweight and fast.
The lang environment variable specifies the locale and its encoding for the current session. Here, my session uses English encoded in UTF-8. To isolate only the encoding, I echo the lang variable and pipe the output to sed. Sed matches anything followed by a dot, followed again by anything, which I store in brackets. Then it substitutes the matching part with \1, which is the first thing it stored. In this way, I isolate the encoding and UTF-8 is displayed. A more efficient way to do this is by invoking the, again smaller and more specialized, expr command. I specify the lang variable as the first argument and use the colon, a regular expression matching, operator. Next, I specify the matching pattern as a regular expression. Within the set of \open and close brackets, I specify the expression's output part. As you can see, we get again the same result, UTF-8.
We finish off by looking at 3 alternative ways through which we can apply a command to a list of files that we get from the find command.
Consider the task of listing all files named core under a specific directory hierarchy. One way to do this is to run ls and use the \* expansion. This recursively searches through the directory hierarchy. However, when there is an excessive number of files to search, a problem may occur. It can exceed the fixed space the operating system allocates for specifying command line arguments. The second option is a more familiar one. I run find on the current directory, specifying core to the -name option. Then I pipe the output to a while loop which reads each file name and invokes ls on it. A third way, instead of the while loop, I can specify the -exec argument to the find command. In this way, I include another command, ls-ld. Through the set of open and close curly brackets, I instruct find to pass as an argument to ls each file found. I terminate the command specification with an escaped semicolon. Both the while loop and the -exec argument have a disadvantage. They invoke one command for each file found. This can be expensive, especially when a large number of files are found. Finally, the fourth way is to use find and pipe the output to xargs. The advantage of this method is that xargs batches a number of files up to the maximum length of command line arguments. Then it invokes the ls command on each batch. This significantly reduces the number of ls invocations and is thus considerably more efficient.
This concludes our professionalism unit on improving your shell style, and with it, the entire course on data, software, and production engineering with Unix command line tools. Thank you for staying with us and for following this course.